Now in this video I'm going to demonstrate how to set up Fisher's multiple comparison procedures using Fisher's LSD for the problem that we just completed, the experimental study of 3 assembly methods. Now let's assume that our alpha is 5%. The degrees of freedom comes from MSE and from the output previously completed. Okay, so you have the degrees of freedom for the error degrees of freedom. So the t table value, t sub alpha over 2 is t table value. So that will be t dot inv dot 2t alpha comma degrees of freedom. This will give us the t table value. Then we have 3 distinct pairs. When we have 3 means, mu sub 1, mu sub 2, mu sub 3, we get 3 unique pairs. Mu sub 1 equal to mu sub 2 or not is the first one. Then mu sub 1 equal to mu sub 3 or not. And then mu sub 2 equal to mu sub 3 or not. So these are the 3 possible pairs. First comparison is between the first sample and the second sample. So it is the sample observations. We can get it from the ANOVA data analysis output or the output that we set up earlier. So n sub 1 is B33 and C33 is n sub 2 and B33 and D33 is 1 and 3. Then C33 and D33 for 2 and 3. In this case, of course, they are all the same value. Now the standard error is that part. So we have square root of MSE. Okay. Again, we can get the MSE from either this ANOVA table or the ANOVA table that data analysis generate times 1 over n sub 1 plus 1 over n sub 2. So that gives us this standard error. We need to make sure that D47 is absolute referenced. And then we copy it. Then LSD is t table value times the standard error. T table value must be absolute referenced. Now here the MSE is the within groups MS mean square. Okay, so now we have to find the absolute value of the difference in the means. The first one is mean of 1, sample 1 minus sample 2. The second one is the absolute value of the difference between sample 1 and sample 3. And the last one is absolute value of the difference between sample 2 and sample 3. Now, if the absolute difference is greater than LSD, then we can reject. So here it is not greater, So you do not reject HO. And the next two, the absolute value of the difference is greater than LSD, so we can reject H sub O in these two cases. So then we can provide an interpretation for these rejections, and you can see that mean 1 and mean 2, you cannot say they are unequal. But mean 1 and mean 3 are unequal, mean 2 and mean 3 are unequal. So it looks like mu of 3, mu sub 3 is the one that is different from mu sub 1 and mu sub 2. And so we can say that there is sufficient evidence to conclude the average production of method C is different from the other two, with the probability of type 1 error being 5%. But in reality, the probability of type 1 error is probably more than 5% because we are doing several hypothesis tests all at the same time. So we really need to make an adjustment for that. So if we want overall level of significance of 5%, then we are making 3 comparisons in this case. So we need to divide 5% by the number of comparisons we are making and use that in the T table. So degrees of freedom is the same as before. Now we use T dot INV dot 2T with that revised alpha and degrees of freedom. So that gives you a larger value for the T table. Then we can get the values of the samples from the way we have set it up the previous table. And the standard error is the same as the previous case. So we can simply bring it down from here, copy that. But LSD will be different because we have new T table value now. Now we need to use this T table value, say 4 times the standard error. Okay. The absolute value of the differences in sample means is the same as previously done. So we get the same results as before. The first one is not greater than LSD, so we cannot reject the null hypothesis. The second and third are different. So the conclusion is same as before. Okay. In this case, it turned out that the Bonferroni adjustment also gave us the same answer, but that need not be so. So if you want overall 5%, not individual 5%, then you have to make this Bonferroni adjustment.